In this video, I am going to try to convince you that this box here has to be true, and then we're going to go on and do some examples. You should have just practiced some U-sub. My computer caught on fire, blew up, whatever you want to think. The recording got all messed up, so I kind of had to start it. That was nice and short. So, you should know that the derivative with respect to x of ln of x is 1 over x. Learned that a long time ago. You might have to remember it, but we learned it a long time ago. The derivative with respect to x of ln of x is 1 over x. So usually when we have one side derived to the other, then if I were to go backwards, it would be integration. So the most logical thing to think would be like, oh, I know 1 over x is going to integrate to ln of x. Let me give you an example that's similar to that. Say I have the derivative with respect to x of x to the fifth. That is equal to 5x to the fourth. So this derives here, and this integrates here. That's the way most of these equations, all these derivative rules, and integral rules, that's the way most of them work. The ln is a little bit different, and in order to explain it, so this is the formula for the integral of 1 over x. It's not ln of x, it's ln of the absolute value of x plus a constant. So I am going to pop over to Desmos to try to explain this to you, and I think it will make sense. Okay, so take a look here. In red, I've got ln. In blue, I've got 1 over x. And here's the formula that I'm trying to convince you is true. So let's first convince you that ln derives to 1 over x, or could, visually. Look at this thing. The red graph is ln, natural log. This graph is constantly increasing. It is going up. That means its derivative should be positive. Notice this blue graph, the 1 over x, which I'm saying is its derivative, is positive. Okay, that matches. Next, see over here at this spot, it's super steep. See here, it's steep, but not as steep. The further I go, the less it steepens, right? The further I go, the closer it gets to flat. It never actually totally flattens out, but it gets the slope gets smaller and smaller. So this graph right here matches that idea in terms of the slope. This is really big and positive. It's really big and positive, but not quite as big. It's pretty big and positive. Well, I guess it's only 1 there, but whatever. And it gets smaller and smaller and smaller, but stays positive. Gets closer and closer to 0. So if I were to graph a bunch of slopes on this thing, it would match this. So it makes sense that the derivative of the red graph, ln, is 1 over x visually. Now, here's the problem. Usually, we say if something derives like this, it would integrate like this. So let's look at where the 1 over x is actually defined versus where the ln of x is defined. Notice ln, and you should know this from like algebra 2 or whatever. I'm not going to go over why ln doesn't have why you can't take the ln of a negative number. But here, notice this natural log only exists for positive numbers. I can't take the ln of a negative number. So it's fine that 1 over x derives to this red function. Or sorry, that the red function derives to the blue function. But if I want to integrate the blue function, notice the blue function is defined here, and it's also defined over here. So I can't say the integral of 1 over x is natural log because this ln of this 1 over x over here wouldn't have an integral, but it clearly would have area underneath of it. So I need to have some kind of curve over on this left side that fits the slope of this thing. Now, one thing I'd like to point out to you with 1 over x is there's like a lot of symmetry here. This guy is essentially the same thing as this guy, except they're flipped. So watch what happens when I throw this ln of absolute value of x in. Bam! See that? It traced over the ln here, so it kept the natural log on the right side, and then drew a mirror image of the ln over here. Why does that do that? Well, for example, let's take this value at 4. The ln of 4 is that thing. If I want to do the ln of negative 4, I can't do it. It won't evaluate for the red function. But what if I put an absolute value in here? Well, if I plug in negative 4 to this, it gives me the ln of the absolute value of -4. The absolute value turns the -4 into a +4, and then makes me take the ln. So what do I get out here? I get the same height out that I got over there. So it's a total mirror image. Now, I said this thing here is the same shape as this thing here. But look, I said this thing is this right here would derive to that. What I would argue is that this green right here would derive to this because it is the mirror image over here. Here's why. Notice let's actually start in here. Here, it is super steep. The green is super steep. I got to stop saying it. The green is super steep, but also going down. So it's got a negative slope, a really big negative slope. What's that look like? Well, bam, way down here. Here it's steep. Actually, look, this steepness right here is the same as that steepness right here, right? Those two spots. So, but notice it's going down as opposed to going up. So this gets a positive slope. This gets a negative slope. This is a really hard thing to explain, and I'm trying, but hopefully this helps you see why I need that absolute value, because I need this side over here to have a integral as well, just like this side does. And they're mirror images, so they got to match each other, but one's going up and one's going down. So therefore, I flip them around like that. Hope that helps a little bit, and now we'll pop back. So I'm going to do a bunch of examples here for you. First one, integral of 3 over x dx. Well, that's the same as 3 integral 1 over x dx, which gives me 3 ln absolute value of x plus a constant. Now, if this was an AP multiple choice question, the answer might show up like this, but it might also show up in another form. Do you know what I can do with that 3? It's a rule. It's a rule called the Plog rule. If you know what I'm talking about, you should say, oh yeah, ln of x cubed, because we can drag this guy in and make it a power. P log of x is log of x to the p. Plog rule. Okay, next one. Let's do the integral from e to e cubed of 10 over x dx. So this is 10 integral from e to e cubed of 1 over x dx, which is 10 ln absolute value of x evaluated from e to e cubed. Now you may say, why aren't you plugging it here? And I'm not doing that just because it's going to make my operations a little bit easier here. So this is the way that I like to typically write these definite integrals, is write the 10 out front and then put some brackets or parentheses and write ln of the top one, e cubed, minus ln of the bottom one, e. Now, you should be able to do these logs because we've done them as a class. This is, remember, ln and e to the cancel. So what's ln of e to the third? Well, that just gives me 10, open bracket, close bracket. ln e to the third, they cancel, it gives me a 3. And then, how do I do this one? Natural log of e. Well, remember, this is e to the first power. So ln of e to the cancels and gives me a 1. From there, I just need to subtract, which gives me 2, and multiply, which gives me 20. Let's do another one. Okay, we will do, this was number 2, this is number 3. We will do the integral from e to root e of 6 over x dx. Well, I'm going to skip this middle step, pulling the 10 out, and I'm just going to write this as 6 ln absolute value of x evaluated from e to root e, which that gives me 6, and then I'll do a parenthesis instead of a bracket this time. I got ln of root e minus ln of e. I think that you should be okay with this one being 1 because ln of e up here was 1. Question is, what's this? Well, Maybe I'll do some scratch work. I'm missing a parenthesis. I'll write, I'll do a little scratch work here. ln of root e is ln. Remember, I can write the root as a half power. So now I can do my cancellation. ln of e to the is the. So ln of e to the half is just a half. From there, I get equals 6, open parentheses. This guy is a half, so times 1 half minus 1, which that gives me 6 times a negative half, which is a negative 3. I'm going to stop here with these examples and then start a new video for the next ones we're going to do.